be relatively quick. I've got like 6 or 7 slides. The focus for the conversation this time is VR locomotion. My focus is VR locomotion. Specifically, I want to talk to you guys about how even if you have excellent hardware, even if you have last gen headset and an excellent computer, if you're developing with a poor VR locomotion system, you're going to cause motion sickness in your users. And a lot of people who have tried VR will come and tell me VR is not going to work, VR is not there yet because I tried it and it gave me motion sickness. Usually they're talking about one of the more uncomfortable versions of VR locomotion, and I'm going to talk to you about 4 specific categories of VR locomotion, 2 main categories, so that you can learn as developers how to develop more comfortable solutions, and as users and enthusiasts how to share VR with people in the most comfortable, easy to access way, and then they can evolve to the more difficult but more intense locomotion solutions. So, the 2 main categories are natural locomotion and artificial locomotion, exactly as they sound. So, natural locomotion in virtual reality is all of your motions are being mapped one-to-one to your virtual character. If you move your head a little bit, the character moves. If you walk forward, the character walks forward. That sounds like it would be more comfortable, and it is more comfortable. So the 2 subcategories of natural locomotion are stationary, which you can generally think of like Gear VR or Oculus Rift. You're in one position, you're not actually physically moving very far. And room scale, you can think about the HTC Vive, where you have an entire play space, and it can get bigger than like a small room, it can be a warehouse size, but the idea of room scale is that you're physically walking and your character is physically walking, and that's also relatively comfortable. The more uncomfortable solutions, but the ones that people keep implementing because they greatly expand your opportunities as a developer, are artificial locomotion. You don't film an entire movie in one room. People have, and they've made good films, but generally speaking, the best films are the ones that go over here, go over there, like move around a lot. And that's true in VR. Like, you want to have multiple environments, you want to have a story, you want to have people scale Mount Everest, but you can't fit Mount Everest in your room. So we invent these solutions in artificial locomotion, how to simulate motion without actually moving. So the 2 main categories are cockpit artificial locomotion, where you're driving a car, you're flying a plane, you have a visual frame of reference. And the reason that's important is because your brain can see that frame of reference, and it can say, okay, the frame is not moving with respect to me, so it's not that absurd for me to not be moving. It's kind of like watching on like a really big TV. Like, the TV is huge, the TV is a fighter jet flying through the sky, but you don't get motion sickness because you see your living room around the box of the TV, and you say, okay, it's fine because I'm not moving. And then the most uncomfortable form of VR locomotion, but potentially the most exciting, is artificial unobstructed. Games where you as a person are flying around, or any games that are ported from like just regular PC games. If you want to play Halo, if you want to play Mirror's Edge, there are injectors that let you play those in virtual reality, and people try them and they come out puking. It's not just because the experience is an insane experience, it's also because the experience is artificial unobstructed locomotion. Your brain has a visual vestibular conflict where what you see doesn't match what you feel, and there's no grounding point. The one caveat to natural locomotion that I'm going to get into is that most people will include teleportation in natural locomotion because you're not actually feeling acceleration. You're moving from one point to another so quickly that you're basically blinking. So you don't get sick from that, most people. So, natural stationary. First category that I was going to go through. Here's just some example games. I can talk to any of them specifically, but the 3 main categories from a developer perspective, if you want the most comfortable experience, and there are more than just these 3, but the most comfortable experiences are tabletop games, where you have like virtual Dungeons and Dragons or virtual card games, where you'll have like an ecosystem in front of you and you're just caring for that ecosystem. That's really simple because you don't have to move very far, you don't have a lot going on elsewhere, you're just kind of, leaning in, looking around, enjoying the experience. Vantage point is kind of like tabletop, except for everything's happening around you. So there are some games or experiences, this isn't all games, this is true about everything. This is true about simulations. If you're going to run a medical simulation, and if that simulation has to have locomotion, you want it to be comfortable. But if you go ahead and do natural stationary vantage point, then that means you as a character, you don't have to walk around. Everything that's important to your character is around you. You have gaze-based controls. You can press buttons and things happen in the world, but the point is you're not moving. And then the last one, like we talked about, is teleportation. There are some people who I've talked to who do get sick because of teleportation, but generally speaking, if it's done well, if you've got like a fade out and a fade in, something along those lines to help somebody understand that they're supposed to be teleporting, it's not that disorienting. Moving down the scale to a little bit less comfortable on, these are all HTC Vive games specifically because that's the only one out now that's room scale. It's a little bit more disorienting to be like walking around, but it's still okay because you're still doing natural motion. It's still one-to-one communication. Stationary room scale are the safest because it's one room and you're in that room the entire time. That room does not move. So like Tilt Brush, it's an amazing game by Google. You just draw in the space around you and you're not allowed to move that room. You're not allowed to go outside of that room. It sounds limiting when I'm talking about it, but once you get in there and you see the room, you say, all right, this is what I've got. This is what I've got to work with. You get by. You can also teleport a room, similar to personal teleportation, but instead you're teleporting the entire room someplace else. And then this last one, I can only think of one game specifically called Hover Junkers, which is a cockpit room. And this kind of bridges the gap between natural and artificial locomotion. We're getting into the slightly more exciting, but also the slightly more nauseating realm. So in Hover Junkers, you have a room and you can walk around. Is that a question?
Sorry, stretching my
In Hover Junkers, you can walk around the room, which is your ship. And you can, build structures, you can build defenses around the room, but then in addition to that, you can control your hover ship to move on its own. So that type of motion is cockpit locomotion, which is artificial, and that becomes more nauseating. That's it on natural locomotion. Any questions on natural locomotion? Okay.
I do have a question
Oh,
this time.
sorry, I just ignored you. I saw the hand
Dual
again.
purpose this time. I'm wondering if you've ever done any experiments with, or what the results are from something that's live, like a 360 video. Or these are all games, right? Like this. But has there been any sort of, what sort of?
So one of the difficulties in figuring out how locomotion works in 360 video is that 360 video tends to, it's VR, you have the sphere around you, but generally speaking, you don't walk around inside the sphere, you don't move around inside the sphere. If you put on a Gear VR and you watch a 360 video, it is highly recommended to not lean and try to look around that video because the video is not going to respond. The physical camera that recorded that video is not responding. So it's different when you have a video of the real world versus like a virtual camera in a game because you can move that virtual camera around.
So is the reason why you can't, to create a 360 video, if you're going to have it moving, like the camera's moving, you can't do that because of the stitching? Is that why if it's live?
So the problem with that is just that, like, physically your camera is not moving. Like, we've got two 360 cameras here, and if I wanted to watch this recording later from the perspective of this camera, I can only watch from this perspective. Even though it feels slight, when I move my head, a foot to the left, you're going to get different occlusion, which is like different blockings, different perspectives of the room around you. There might be something, like if I held this here and I held my hand here, then the camera can't see it, but if you move just 6 inches to the left, then your virtual head there would be able to see the mouse. And there's no way with regular 360 video recording to fill in those gaps. There are some software techniques where you can approximate them for a little bit of motion, like the physical motion that happens when you turn your head. your eyes are not turning around one point, you're not turning around your eyes, you're turning around your neck. So there are head-neck models that will fill in the gaps from just a couple inch motion. And then we had a guy here last time who was involved in the Lytro project, where Lytro, as a 360 film company, they're focusing on these things called light fields, and they actually have a sphere camera. That is just a bunch of little cameras everywhere else, and they digitally reconstruct the perspective from every single point on and in that sphere, which means it's a lot of heavy software. They've got big, heavy, expensive, hot servers that run it. And because they're digitally reconstructing a real world, you can move anywhere within that sphere. But most cameras, highly recommended, don't move, don't lean, just look around and enjoy it from there. Any other questions? Okay. Moving on to artificial locomotion. So, like I said, generally speaking, the reason why artificial locomotion is still around is because the games tend to be more fun. You tend to have more opportunities to do more, go more. People want to be pilots, people want to be race car drivers, and you can't fit a race car track into your room. But Cockpit, which is all three of these, are the more comfortable of the artificial locomotion solutions. If you have any logic in your game or experience to put someone in a cockpit, do it. If you're going to do a game where you're in space and you're floating around, it might be fun to see the stars in your peripheral, but it's highly recommended to put that character in a helmet so that when they move their head around, the helmet moves around too. And that's not literally a cockpit, but that gives them a frame of reference in order to lock. Their brain can find something and stick to that, and that really helps with the knowledge. There's a game out now called Adrift, which is already being kind of hit hard from reviewers for motion sickness, but if they didn't put you in a helmet, then nobody would want to play that game. And this is all on a spectrum. There are some solutions that people have been implementing where you actually will only see like a virtual nose of a virtual character. And that doesn't sound like it would help a lot, but it really does, because you don't think about it, but a lot of people can see their nose in real life, and even if you have a little cute nose and you're not used to seeing a big nose, you quickly accept the fact that you have a big nose, and your brain uses your big nose as a locking system for motion in VR. Any questions on Cockpit, artificial locomotion? Okay. No. Okay. And then the last form of locomotion, the last form of software locomotion, because this is a developer conference, I'll get to hardware in a minute because I like that. The last form of artificial locomotion is what we've been talking about. It's artificial, unobstructed. I put 3 categories here, but this is the easiest category to think of more subcategories. So this is any time that your player, your virtual character is moving and you in the real world aren't, and you don't have a cockpit frame of reference. So the 3 most common ones, 2 very popular launch titles from actually no, I think one of them's not a launch title. 2 very popular titles from Oculus do use a floating rail system where they do artificial locomotion, but they do it very slowly. You control a character who's running around, and your virtual character just floats behind them. And that's, generally speaking, the most comfortable form of unobstructed artificial locomotion. Kind of going a little heavier, traditional rail. I'm sure everyone who's like really, really into VR has seen the videos online on YouTube where people are doing like a roller coaster and they're freaking out, and those are funny videos, but that's also really bad for VR in general because it is the second worst form of locomotion. People are most likely to get sick, not because it's a roller coaster that's like a really well done roller coaster with lots of loops. They're most likely to get sick because it's artificial unobstructed locomotion. So if somebody said, whatever, I tried a VR roller coaster and it made me sick and I hate VR, put them in a comfortable, natural locomotion system. And as we do demos later, I'm going to be walking around asking people what form of locomotion their demo is. So if you haven't been paying attention, that's kind of the way I'll quiz people. And then the last one is player-controlled artificial unobstructed locomotion. This one is the worst. This one's the Halos and the Mirror's Edge. And any first-person shooter where you have an analog joystick or WASD, and that's your input, and your character goes where you want to go. Generally speaking, the least comfortable. So yeah, that's, any questions on artificial uninstructed locomotion? Guess I'm doing a good job, no questions?
Absolutely.
Cool. And then lastly, before I close off, personally, I'm a hardware guy. I love the hardware. The reason why I didn't go too much into depth on this stuff is because the software implementation is intentionally easy. People don't design for the Virtuix Omni, which, if anybody hasn't heard of it, it is a omnidirectional treadmill. It uses a slip system where you take a step and it slips your step back to the middle, but your motion is recognized by the system as a step. So when you take a real step in the real world, your virtual character takes a virtual step in the virtual world. This helps a fair amount because you at least feel like you're stepping. You don't actually feel the acceleration of a step, but you feel the foot motion. But from a developer perspective, it's intentionally easy to develop for these things because you can just develop a system that is, navigating however you want, not however you want to do. If you're navigating via WASD or via an analog joystick, and somebody tries to use this, there's very simple tools where you can just remap their walking to, they walk to the left, then it's essentially pressing W, or no, A. It's the joystick to the left. So the top three are consumer omnidirectional treadmills. They're priced right now at about $700 to $1,500, so they're definitely for enthusiasts. There's not a lot of games supporting them right now, even though it's I say relatively easy. It's easier than designing a whole game, and you don't have to design specifically for this. But right now, there's just not enough people who are using these devices to really make it worth it for most people to put it as like a high priority. And then something that's even more interesting to me personally is commercial omnidirectional treadmills. So these are really big, really heavy, really expensive, but also really effective forms of real locomotion, where you're actually walking in the real world and it's actually translating to long distance walking in the virtual world. So these are going to be implemented in research, training. The Virtusphere in the middle, that's been around for like a decade, and they've done a fair amount of military training. You can run, you can jump, you can do whatever you need to in there. Infinideck, they're kind of looking more towards like the virtual reality arcades. It's a higher price point, but normal consumers will be able to access it. And that's about it on commercial. Thank you. Any questions on VR locomotion in general? Anything I talked about?
Can you make these slides available online?
Yeah. Yeah, I'll put them on the Facebook page. Cool.
I think he gets it.
Thank you. So yeah, that ends the formal part of this meeting. You guys are just welcome to chill and hang out and network and talk to people. Again, the Facebook group, VARDNET, VARDNET, Virtual and Augmented Reality Developers Network. It's the only one. And also the Meetup group, be good. And then that Knox Devs channel, Slack channel, if anybody y'all are out here is slacking. So yeah, thank you all for coming, and stay and hang out. We'll be here for a while. So thank you guys.
You want me to play that video? I mean, if you want to. The sound I don't think outputs. You know what I'm saying?
The only time there's sound in the video is when I'm speaking or the game is developing on it.
Oh, okay, so there's no sound in it.
Well, there's a little. There's where I say select and where it's plays out. Yeah, people keep.
Yeah, you have to do this hand. You didn't really actually trick anybody. And then you have like this little reticle, and it's always staying there. You look and you're like, this, what does that mean? It's like you're doing this thing every lot sometimes.
Now I guess I need to watch it.
You guys never seen it go in. I'm going to do game 2. I mean, that's right. It's a lot because it's not just a headset, which is a lot. It's also 2 room space. And the control. For the room space, you have to have an outlet somewhere. So that's kind of a pain. Bigger room you have, the more you can do. Scale down, you can't scale up. So like job simulators. Your space is too small, you can't do some of the jobs. Cool, man.
Yes, this is all I can think of is as I was I have a video that I'm not sure when they play on stage. Some screenshots of what it looks like through the glass. Because I've seen their demos where they sort of do like a large production camera, like a movie, which, you know, because they got the screen there. So it actually captures the full hologram. I guess it's not working either because there's so many people over there, but I used to be able to get a live view of it to see exactly what they see, including the live. But I think there's a lot of cell phones in it. So that's not really working. But, is that it? Is that it? Right now, this is, yeah, I'm going to see it's network access. Check off. Me, what I've been looking over here at is what all programs look like. As I found out, I can just a little bit to just keep pushing stuff. Well, I try to push the idea that we get up and explain it a bit more. Because what I was going to do is just have a hologram or like a couple of holograms and allow them to look at it. Once you start looking at the games, they get very right.